Hey there. Previously, we added an app component that displays the application's title as well as the wallet info from the backend. The app component makes a request to the wallet info endpoint and renders the returned data. So let's use a similar strategy to address the main point of building this frontend at all, which is to visualize the blockchain. To start, we're going to create a blocks component, since we're going to be using the data from the blocks endpoint of the backend. So this starts in a block.js file right next to the app.js file in the components directory. Notice again that it's plural blocks. Like the app component, we're going to import the React library as well as the component class from the React module. Then let's declare our blocks class and have it extend the component class from React. Cool. So our class of block extends the component class from React. This blocks component will make a request to the blocks endpoint of the backend, which is going to return an array of blocks. We'll want to store that returned array of blocks in the component itself. Therefore, we're going to have a state field, which has a blocks key, and the return value of the blocks endpoint is an array. So by default, blocks is going to be an empty array. Then in a component did mount lifecycle hook, we can take care of fetching the data from the backend. So we're pretty much following the same pattern that we've set in our app component, which fetches the wallet info. But now we're going to fetch http ://localhost 3000 /API/blocks. We then follow with a .then handler, which has a callback function as its parameter. And this callback function gets the response from the fetch, and this itself has a response.json method. This returns a promise as well, so we have a callback, but this time we get to use the JSON. And then with the result, which should be the blocks from the backend, we'll set the local blocks in the state to the resulting JSON payload, which is going to be that array of blocks, which represents the blockchain. All right, cool. So now we have a successful API blocks request. This leads us to the render method of the component. In here, we can define the overall structure of the blocks. So make sure to have the return statement, and we're going to start with an overall div. We'll also provide a title that marks this as the blocks array. And let's use a pair of header 3 tags, which is a pretty large piece of text. So it's larger than the text you'd see for the regular divs in the application. All right. And after this change, let's make sure to export this default blocks component. In other words, we're exporting the blocks component as the default for this file. Right after this, let's actually include the blocks in our main app component render. However, in order to make sure that this component mount fetch is working, what we can do is add a console.log in the render method of this.state. So overall, it's going to log this.state, which contains our block state. And once this component mount fetch finishes, we should get a new call to render and then a new log of this.state, but then this time, the blocks is going to be updated with the JSON payload from our fetch request. All right. Now, in order to see this in action, once you have all of these changes, head to the app.js file. Then let's import the local blocks component from its blocks file. And notice we don't need the .js extension that is used implicitly. And now below the balance, let's render the blocks component itself. And this one can be a self-enclosing tag, just like our app component in the main source index.js file, since it doesn't have anything rendered within its tags. To also make some separation, let's add a break component over here. So this is a BR component with self-enclosing tags itself. And all this does is it adds some horizontal space between divs in a component. All right, with all of that, go to the command line and make sure the application is running with an npm run dev. Now, if you already have it running in the background, this is in dev mode, so it should have picked up and rebuilt the application. And then go ahead and visit localhost 3000 in the browser. And already, it might have reloaded for you and loaded the blocks component, but let's give it a refresh so it can make its fetch request. And this is now a little too zoomed in, But you'll notice that this header 3 component is a little large and emboldened. That is the effect of the H3. If you inspect the element and go to the console, we're looking for that log of this.state. And we get 3 logs, so once when the component is created, once when it starts loading, and once when it finally gets to the component did mount. So here are the blocks. And indeed, it's an array of blocks, which right now only consists of one piece of data, and that is the Genesis block that we've created in the backend. Cool. So now that we have this array logging into the console from the this.state, we now have the most important part to render, which is the array of blocks itself. So we got the data, let's make sure it appears in the component. All right, so back to the code in blocks.js. The trick is we can't simply throw the data structure like an array or object that is complex. So it might be tempting to try and do this.state.blocks and see what this results in. So let's go ahead and try. Let's give it a refresh, but you're going to see in the console an error, which says objects are not valid as React children. So an array is a complex kind of object itself. Therefore, it can't be rendered directly within the JSX. Right now, we're trying to render it as a child within the app component. The only thing that we can have as valid JSX are things like divs, h3 tags like we've seen, or other things that we'll get to later like input tags as well as button tags. So what is our approach to rendering this blocks array? Well, the idea is that even though we can't directly render the array itself, we can transform this array into an array of renderable content. So let's start by emptying this pair of curly braces, and this pair of curly braces now allows us to use dynamic content. Then let's take the state of the blocks, and instead of directly rendering it, we're going to map over that array and return some other kind of array. This takes a callback function, and one at a time we can render something for every single block. Okay, and for each block item, let's return a new piece of JSX. Let's have a div for now, and this div is going to have some rendered inline JSX that is the block.hash. Cool. So when React gets to this JavaScript is going to be mapped out. It's going to be as if we actually wrote the JSX for each block individually in the blocks array. So this map method is very convenient for our use case when we want to render an array of data in JSX form, or in any arbitrary JSX form for that matter, because we have complete control over what it returns in the JSX for each item in the array. All right, nice. So let's go ahead and save this and then check it out in the browser. And as we refresh the browser, well, you should see that now hash1 appears in the actual application. Cool, so the map method is working. But you're going to notice that in the console, even though it's technically working, we see one error, and that is each child in an array or iterator should have a unique key prop. So this is a key React warning that is telling us it's not optimal to have a situation where there are duplicate keys of JSX, or rather duplicate pieces of JSX, right next to each other in a React component. The underlying React engine needs to have a way to distinguish these subsequent pieces of JSX from each other. Now, luckily, the block.hash is already a unique key property of the block object. It's unique to every single item. So therefore, we can use that as the key property on the block itself. So for the overall div that is rendering the block.hash, let's also have a key property within here that is also block.hash. All right, once you have that change, on a refresh now, what you should find is that the error disappears. Cool. Now, we're still only seeing the Genesis block, but that's because our backend hasn't added any new blocks through post request to add transactional data to the blockchain just yet. Now, we could go through opening Postman, configuring a couple of transactions, and then making a post request to mine those transactions, so that way we could see another new block on the front end. But we're going to be saving up this front end a lot, which includes restarting the entire backend. So to save us some time as we're developing, let's see the backend with data by running the code to essentially do what we do through various post requests, except automatically every time we're going to conduct around 20 or so transactions. and include a bunch of blocks so that way you can see all those blocks on the front end every time we make a change without having to go through the Postman route every time. In addition, after that, we're going to take some time to make sure our application doesn't look so old school anymore and actually stylize the application. But in the meantime, let's see the backend with data next.